We turn our attention now to the use of tools where the main focus is upon safety. Always keep in mind that you are in total control of a hand tool. You supply the power, and you make the tool do just what you want it to. Some practical tips concerning the use of spanners are: always select the correct size, maintain a well-balanced and comfortable position. Should the spanner slip for any reason, you will not fall. Whenever possible, apply force through pulling, as this way you have better control. Again, should the spanner slip, you are less likely to fall forward as you might if you push. On occasion, you may be forced into a situation where you can only push. In such a case, try using the open hand bumping method as demonstrated. This method is often used when loosening a tight nut or set screw. Where a really strong pull is required, such as here on the wheel nuts of this tractor, keep your back as straight as possible. Use your leg muscles and arms whilst maintaining a firm grip upon the spanner as demonstrated. Keep your hands dry by wiping, thus avoiding a tool slipping. Regarding screwdrivers, always keep the shank straight in line with the screw. Maintain enough force upon the screw head to keep the tip from slipping as you turn the screw. On a very tight screw, it may first be necessary to give the screw head a firm blow or two, using a soft metal drift to release the bite. We now offer you some practical tips in general tool usage. When there is a nut and bolt combination, always apply the loosening or the tightening force to the nut using a ring spanner or socket spanner. A flat spanner is used simply to support and hold the bolt head. When loosening Allen cap screws, you may find that the leverage on the key is not enough to loosen the screw. As with other screws, a couple of sharp knocks will often help to unfreeze a stubborn fastener. If an Allen key cannot perform the task, then try using a socket drive. The bad practice of extending an Allen key, with a pipe for example, will result in damaged fastener heads and damaged tools. Knowing just how tight to secure a fastener using standard hand tools is pure guesswork. The result of over-tightening is generally a broken fastener or a stripped thread. There is, however, only one sure method of assessing tightness, and that is with a torque wrench. This is a typical torque wrench, which, like most other types, must be used in conjunction with socket drivers and socket spanners. This type is known as a preset torque wrench. The desired torque is obtained by adjusting, as demonstrated, within the handle. Once set, the tool is assembled using the desired socket drive accessories and the fasteners tightened. When the preset torque has been reached, the wrench produces an audible click. Several varieties of torque wrenches are available. Ask your instructor to show and demonstrate the type used by your company. By now, you may be asking the question, what on earth is torque? So we shall attempt to explain. In simple terms, torque is the measure of turning force. For example, by pulling on a lever at one end, we will create torque at the opposite end. By extending the length of the lever and maintaining the same pulling effort, we will create a higher torque. We express torque in units called Newton meters. All torque wrenches in metric standards are calibrated in Newton meters. Imperial standards are given in foot-pounds, a unit of torque measure still used in some countries. Should you ever need to convert specifications, 1 foot-pound is equivalent to 0,75 Newton meters. When we use a torque wrench, we are, in effect, simply providing a pull over a distance, which is the length of the handle. The scale provides visual reference as to the torque being created at the socket end. The actual torque settings, or specifications, for various fasteners are affected by many factors, such as size, material, pitch, and even the type of lubrication used on a thread. We urge you to follow the specifications provided in workshop manuals or specification tables provided by the equipment manufacturers always. In the following demonstration, we shall proceed to torque up these main bearing cap screws to the specified torque. The specified torque is looked up in the specification manual. In our demonstration, we are using a pin release preset type torque wrench. Adjustment is made as demonstrated until the scale indicator aligns to the specified Newton meter setting. At this time, the indicator pin is pushed into its locked position. Tightening of each set screw is now performed until the pin releases, indicating that the preset torque has been reached. Each fastener, in its correct sequence, is now tightened to exactly the specified degree of tightness. The precise tightening sequence and procedure for various components should be followed according to manufacturer's instructions. Always keep in mind that a torque wrench is a precision tool and must be treated properly. A torque wrench is never to be used for loosening, as this will upset its calibration. Always pull a torque wrench and pull it smoothly. Never snatch or jerk, as this too will render inaccurate results. With preset types, it is advisable to set the adjustment to its lowest setting once the work is completed. Doing this will help keep the instrument accurately calibrated. This brings us to the end of Program 4. Join us again in the following program, where you will learn more on the subject of fastening devices.